All right. Hey, everybody. Hope you're doing well today. Here's another rendition of Zephyr 101. I'm Jared. And we're going to be talking about some good things here. Let me just double check the audio is working. Oh, yeah, it is working. I'm going to pause myself so not to distract it. So we're going to be talking about adding Bluetooth to an NRF9160 based project. So it does require some extra hardware. But once you kind of get it configured, it's pretty cool. This is one of the things that really got me excited about Zephyr is the fact that you can literally kind of add on, bolt on features that don't come with a particular chip, in this case the NRF52, and all of a sudden you have them. So let's jump in. If you haven't already subscribed, hit that subscribe button. Leave a comment down below. Let me know about the things that you'd like to see. I'd love to hear from you. So, and that's one of the things about this is that today is a community suggestion from Christopher. So he says, let's say you have an NRF9160 Feather and you want to interface BLE on an NRF5340 or 52840. How would you do this? So we'll be talking about that today. I am using an NRF52833 rather than an 840, but I've done it on both and it works very well. In some cases, you can get away with the NRF52833. You don't need the 840. 840 is really meant for kind of more processor / space intensive applications, things that use thread or even matter. Forgot the name of it for a second. But in this case, all we need is an NR52 that's able to do Bluetooth. So Zephyr has a built-in HCI layer that allows you to basically set up a NR52 as a coprocessor. So you, by default in Zephyr, you use a UART interface with flow control turned on, and that's great, but it doesn't really work very well for low power applications. So Nordic went ahead and actually implemented a low power UART implementation, which goes a little bit step further and actually allows your UART interfaces, especially the receivers, to sleep when they're not being used, and this saves a ton of power. If it gives you an idea, like a receiver will draw anywhere between 500 microamps to 1 milliamp. So if you have both receivers on the coprocessor and the NRF9160, we're talking about anywhere between 1 to 2 milliamps, which isn't great. On the other end, I just been doing some work for a customer, and I did this exactly as I will describe it in this presentation today. And for long-term measurement, including publishing and all this other stuff, I'm looking at 30 microamps, and that includes sampling every second, per second, every minute. And that's just one example. So you can get pretty good battery life when you do this, and it's pretty exciting because you get both, the best of both worlds, cellular and BLE. The cool thing is, like I kind of mentioned it before, is you can run and use the BLE APIs on the NRF9160 as if it natively had Bluetooth, which is really cool. And then the HCI, the lower level stack, lives on the BLE coprocessor, and we'll get into that. Here's kind of the very simplified diagram, but these are the kind of the most important parts. You have NRF9160 or whatever chip that maybe doesn't have Bluetooth. To use the low power UART implementation, you're going to have to be using a Nordic chip, I believe, because it is Nordic specific. It is not built into the Zephyr vanilla SDK. So you have that low power UART interface that includes the TXRX and then the equivalents of the CTS RTS, the clear to send, ready to send. And then also you need to interface with the reset pin of the NR52. That allows you to get the NR52 in sync with the NRF9160 when everything boots or maybe something resets. Then you've got to make sure that it's in the right state, and that's one of the kind of the drawback about this is that for if there's something happens where there's if something becomes out of sync, you're kind of SOL, and it usually causes some type of fault on the NRF9160 side. So it would be great to see this implementation a little more fault tolerant in the future, but that's what it is for now, and it actually works pretty well for the most part. A lot of the times it's been problems with the communication interface, the low power UART. There have been some bugs in that over the years, and Nordic has squashed a lot of them, so it's great. So we're going to set up everything on the NR52 side first. We're going to configure the LP UART, low power UART, configuring the reset pin, making sure at least it's turned on, enabling HCI. And I also like turning on RTT. I can actually load up the RTT console and connect my debugger to it just to make sure it's actually loading properly. Here's the general structure of the application. The majority of the application actually lives in the Zephyr, vanilla Zephyr repository. We're actually using CMake lists to point to that particular sample. It's just the HCI UART sample. But we'll see in a second. Right here, you can see you can actually, so when you create an application, you actually can target a main outside of that application folder. So in this case, we're just using the HCI UART main.c. And that does all the magic. Some important things we need here. We need serial, UART interrupt driven. Yes. It'll actually be more important to have async UART turned on, but that's in the next slide, so we'll go to there. But the wait no op is making sure that both, it's kind of an extra sync step to make sure that both are in sync before the NRF91 side and then NRF52. All the rest of it is kind of enabling raw commands, enabling the interface so you can talk to it over HCI. For the board specific, so this is a unreleased board that I've been working on, the NRF52833 Feather. It is a companion board to the NRF9160 Feather, and basically you can plug them in side by side, or you can nest them together, and you can, add your configurations, and you can have a pretty solid working NRF9160 Feather plus Bluetooth interface, which is pretty cool. Ideally, I'd like to have them on the same board sometime in the near future, but this is a stopgap for now. Here are some interesting things that you can also add. For instance, like if you think you're going to be using it as a central, you might want to, or maybe I should take a step back. There are two different kinds of Bluetooth devices. You can either have a peripheral, a central, or you can actually act as both. So I've set like the max connections. This is typically for central if you have multiple devices you want to connect to. Encryption there, turning a tiny encrypt. DTM is direct test mode, allows you to execute test commands for either factory purposes, or if you're doing any type of compliance testing, that is also useful. A lot of these are the defaults that come with the other example. I think I put that in the description. You can definitely check it out. It's one of Nordic's. They're using their HCI LP UART with the NRF9160. I think it's either for the Thingy 91 or the NRF9160 development kit. Here are some important. So this is where we're kind of diving in, where this is important for the communication interface, and it'll break if you don't have these things turned on, and it's dependent on what interface you're using. So just making sure that we're using timer 1. And we're also using UART 1, so those need to be turned on. And then also we're enabling the async interface. So Zephyr actually has three UART kind of implementations. One's kind of a polling architecture, one is an interrupt driven one, and then one is an asynchronous one. Asynchronous one usually is like the FIFO, you're using DMA or something similar. And that is what we want to be using here, is that's what their LP UART driver actually uses. So that is important to have all turned on for the particular interface you're using. So we are using UART 1. And then we also want to make sure that the LP UART driver and the LP UART interrupt driven is also turned on for that particular instance. Those are pretty critical for this to be working. And we're going to have to do the same thing on the NRF9160 side shortly as well. This is important if you have a board that turns off the GPIO. So it's usually pin 18 across all the different parts, but Sometimes it's by default, the reset is turned off, so you can use it as a GPIO, or if you really need it as a GPIO, then, or as a reset pin, then you just gotta reconfigure it. That's pretty cool about the NRF9160 series, is you can save a GPIO if you don't need the reset pin, but if you really need it, you can turn it back on. And then, as I mentioned before, I want to use the UART console rather than worrying about having another UART console, because those are not exactly easily accessible when everything's kind of mated together. We'll jump over to the overlay portion of the NRF52 configuration here, the NRF52 overlay. One thing we need to make sure is that this chosen BT-C2H-UART is actually defined. So we're actually defining the LP UART interface a little bit later under the UART1 interface. So you can see, you'll see in a second in the next slide, but I'm just configuring the speed. We want it as fast as possible. Typically the fastest speed for Nordic parts is 1 MBAud. So that's what I have it configured here. It says 1 million. We're setting up some default pin control definitions, and that's only because I had to use different pins than I originally had thought. But we'll jump to the next section here. So this part actually lives within the UART1. I just took it out just because otherwise it was just going to be way too small. So it was actually living underneath that current speed entry. We're defining the low power UART interface. One other thing you might have to do, and I'll show this in the next slides for the NRF9160, is making sure that the hardware flow control is turned off if it is turned on by default. But we're setting the low power UART interface, we're setting the request pin and the ready pin. And these are the kind of like the CTS, RTS pins for LP UART. The one thing I will mention, and I'll probably mention again, is that when you are matching up these pins, is that UART is infamous for when you're setting up hardware that you end up routing the signals to the wrong pins. Nice thing about these newer chips is that you can kind of swizzle them and do it in software, but a long time ago when UART pins were dedicated to specific pins, you couldn't undo your error if you routed the TX to the TX and the RX to the RX. So RX goes to TX, TX goes to RX. It's confusing on purpose. Here is another important bit here is that the LP UART interface also uses the GPIO driver that is mostly for the request pin and the ready pin, and that just needs to be the same priority as the UART interface. So UART interface is set to some priority, and we just got to make sure that this is also, it will, if you don't have this line, when you build, it'll actually give you a compile time error saying, hey, your GPIO interface does not have the same priority as your UART interface. So, and it'll look different on the NRF91 versus the NRF52. So bear that in mind. We also, so if you're doing a pin control, if you're using non-defaults, you can map these TX-RX signals as necessary. So I've mapped them to port 0, pin 4, and pin 3. And then those stay the same for the sleep one, except you have that low power enable option as well. Just for good measure, I also have turned off a lot of the interfaces. I think they're pretty much off by default anyway, but I just like disabled them because we're not using them. We're literally using one UART interface, and that is UART1. So we've configured the code to build this lower level HCI coprocessor, and we've set it up for UART and low power and the LP UART implementation. We've made sure the GPIO interrupt level is correct. We've remapped UART to match the pins on the NRF9160. And this is going to be arbitrary. This can be whatever pins you want to use. Let's say you're already using the TX-RX for something else. You can have up to two UART interfaces on the NRF9160. So maybe you're interfacing with something else. You can have two running at the same time. That means you do lose your USB to UART interface if you're not using that because you only have two. Enabling that reset pin and debugging via RTT. So I like the RTT option because I can just hook up the debugger and just load into it. See, make sure it's actually loading the code, and also that there's not like rebooting or something terrible happening. Here's the NRF9160 directory structure. This should be for the same for the NRF9161. There's not much differences here. The 61 just has some more features. So, but you can see we've got CMake list, kconfigs, all the normal things that I've talked about in the past. We have child image. I'm not going to go into that, but I did have to change how the LEDs. So version 5 of the NRF9160 Feather changed the polarity of the LED. So I just had to change that for the bootloader, or else it would keep the LED on the whole time. That's not good. One interesting thing here is I did add a custom binding for the NRF52 reset. So we will dive into that as well. And project config main. So here is the NRF9160 side. You're actually turning on Bluetooth. The H4 is like we're going over ACI UART. We're going to wait so that no op. So one side needs to send a no op, the other side needs to send a no op before it can kind of continue. You can see I'm using the central profile. We're just doing some scanning, and this is really dependent on your application. So if you want it to be a peripheral, if you want it to advertise, and you just have that at the peripheral. So that is that's that. If you by default the UART interrupt driven needs to be turned on, but if we're using the async LP UART implementation, then that will change in the overlay here. So here it is again. We're actually using timer number 2. We're using UART number 2. We want to enable LP UART and make sure that all the UART async stuff is turned on as well. All those things are dependencies for this LP UART implementation. So you got to make sure you have the right interface set up, the right timers, and so on and so forth. You can also see here, so the chosen entry is a little bit different compared to the NRF52. It is BT-UART, so that's just a little bit different from on this side, but that's how that's set. Doesn't look very much different from the NR52, but the BT-UART is different. The NR52 reset. So this is the custom binding I was referring to, and all I'm doing is just making sure that I'm setting a GPIO for that purpose. So I'm using port 0, pin 13, and that is used to reset everything. And I'll show you actually the function where that is happening. You can see this GPIO interrupt priority level. We're just syncing priorities with the UART. In this case, that first entry is different than the NR52. The other one was 6. This one is 49. I think that just has to do with the GPIO implementation, whatever. That's what I've seen on there. I actually haven't. So you caught me. I haven't actually dived in to see what those 49 and the 6, but I think the more important thing is that IRQ priority, making sure that's the same. The UART2 here, again, we're setting the baud, make sure it's synchronized across both the NR52 and this guy, so everything's set to 1 meg baud. Turning off or removing, deleting the property hardware flow control if it's there. And then we're also defining the pin control pins. Again, the LP UART implementation should be in between that delete property and pin control, but I put it on this page just to show you. It is indented, so you can see that it's supposed to be inside. And I also wrote in red inside the UART interface. So these are the pins on the NRF9160 side that actually match to the pins on the NRF52 side. So. Doing the pin control, we do some mapping here. There are different pins other than the defaults for this particular interface, so we are setting those up for both the sleep and the normal state, and they are the same. Here is, so that DTS binding, if you from that tree, you can see that I put this file there, and this is the contents. So all we're doing is just adding a GPIO's entry. It is a p-handle array. It's required. And essentially, you put your GPIO in there, and then it'll be, you can look it up with the DT bindings and use it in the function that we'll be talking about next. But this was kind of, Nordic has bindings for the NRF9160 DK or the Thingy 91, but they didn't quite work for this because what was the reason? I couldn't get access to it or something like that. So rather than trying to make that work, it was just easy enough to create my own binding for it. So you can see this is a 15-line file, and it works. Here's the reset code. So this is where things get a little bit interesting. So in order to synchronize everything, we need to hit that reset pin on the NRF52, and this is how we're going to do it. We're getting the DT entries for that GPIO pin, and then we're going to, in the next step here, we're actually overriding a weak implementation of the BT HCI transport setup function. And this allows you to do initialization step during the Bluetooth HCI setup. So this is where all the fun stuff actually happens when we're talking about synchronizing both parts, both chips. So we're configuring that GPIO output, and then we're going to toggle it. So we set it, and then we wait for 10 milliseconds. We actually, let me see, did I miss that part? Or did I not copy it in? I might have not copied it in. But during that sleep state, we're actually going to clear any FIFOs, make sure there's no nasty data in there, and then we're going to kind of clear that reset pin and then return and allow the HCI UART to continue setting up. That gets actually called during the BT_enable process because we've turned on HCI UART on both devices, or in this case, this is the NRF9160 side. It's going to be going down to that HCI level and running all those subroutines. But this should look familiar for anybody who's actually done any Bluetooth stuff on Zephyr. This is the Bluetooth API. You're using Bluetooth enable. You're getting the BLE ready, which is basically just a callback that happens, a second after everything gets set up, and that's the gist of it. And you can use this function to do whatever you need to do once the Bluetooth is ready. I often use this to trigger a scan or advertisement, depends on the code that you're trying to write. So this is, I kind of alluded to this before, configuration is important for this, is making sure that your pins are mapped correctly, and it'll drive you crazy because if something's not working, you just get faults and things time out, and it makes you want to poke out your eyes. But as long as you're diligent and you can map your pins across the ports and make sure that they are on the correct pins, you should have pretty good success. For instance, this board is a brand new board. I had to remap the pins, and besides the reset, I had an issue with getting the reset working. Besides that, it actually kind of booted right up and started working, which is just like hallelujah. So, but that reset pin is critical for getting the NRF9160 and the NRF52 synchronized. And I mentioned this before, is that if something happens during the runtime, there's no real great resynchronization mechanism. So let's say you get some type of error over the bus, something happens. I was seeing this a lot with low power UART implementations in the past, where there would be an error, and then you're like, well, that's great. So what will happen is it'll time out, and then within about 10 seconds, the NRF9160 will say, hey, I'm having issues with the HCI UART. I'm just gonna fault and reboot. Not great. But that is the way it is. More and more now, like I'm seeing, it's much more reliable. They really improved it significantly, but this is kind of like the one gotcha if you find yourself playing with this, is you're just gonna watch out for that. So bear that in mind. So once configured, you can use Bluetooth on the NRF9160 as if it was natively. So you can call those Bluetooth APIs and use it as if. You can use it as a central peripheral, scanning, advertising, all the functions that you would expect. You can create custom characteristics, read and write from them. You could subscribe to them, all that fun stuff. The low power UART, low power is fantastic compared to the default implementation. Like I said, it's 2 milliamps versus tens of microamps. and it's if you're on a low power budget, this will be fantastic because you can kind of use your cellular interface as needed. You can use your Bluetooth interface as needed, and it's not going to break the bank on your batteries. So, and the description has links to that main Nordic sample that I've used as a reference a lot. So you can definitely check that out. And that's it. So let me see if there are any questions. Livio, you're the man. Thanks for being here. Good to see you. Get some familiar faces in the crowd. That's awesome. Let's see if I have any questions. No questions. Well, if you guys do have questions, or if you're watching this after, feel free to leave a comment in the chat box below, and I'd be happy to get to you. Or if you have a topic that you'd like me to cover, please send it my way because that'd be great. I'd love to cover it next week or in an upcoming in an upcoming Zephyr 101. Let's see. Oh, I do have some questions. Andre, are you using vanilla Zephyr or Nordic specific? So for this particular one, I'm using Nordic specific, only because they offer the low power UART implementation. You can use this HCI UART with the vanilla Zephyr, but you won't get that power savings. So, and we got Franz in the house. Good to see ya. And we got Brian. What's up, Brian? Cool. If you haven't already subscribed, I'm gonna get on the screen here, but if you haven't already subscribed, check out my mailing list. You should go to jaredwolf.com and put in your info. I do send out some emails here and there, especially the heads up email for folks who are living in their email box versus living on YouTube. You can kind of get that heads up before these sessions go live. They're around the same time every week, but like this today, it's a little bit later. So, Andre, no problem. Let's see, Saeed. Which scenario, oh, I got more questions. So which scenario is more suitable for the UART component? UART under DMA mode or interrupt mode? It has been observed that UART under interrupt mode may miss significant amount of data. So you're kind of referring to like the UART interrupt for the HCI. I don't quite know if... I think you can either use either one if you're just using vanilla Zephyr, so you can use the async side or you can use the interrupt driven side. I think by default they were using the interrupt driven side, and maybe that's why you've seen it had issues. I always use the async UART implementation now, especially for low power, because I can take advantage of Nordic's LP UART implementation. So you realize that when using Spark from the SAMD21. Yeah, so your miles may vary. Whenever I do anything UART related now, Nordic or NCS or vanilla Zephyr, I always try to use the UART async UART implementation if I'm doing something. I like it a little bit. It's a little bit nicer. It's not anywhere near like if you're used to using serial on like a Arduino or something. It's a little bit more complicated to set up. There's some buffers and FIFOs and events that you need to handle, and buffer requests and things like that get a little tricky. So it does take some time to get used to. So I hope that helps. But I would, if you can, try to this is also one thing I've harped on in the past, is it's all dependent on who's implemented the drivers for your chip that you're using. So there might be drivers for AMD or SAMD21, but they might not have DMA/async implementation for that particular chip. So you just gotta see what's available for it. Fortunately, Nordic has great support for all their drivers, and there was a big community support for those chips a long time before Nordic even came into Zephyr, which is cool. And then Franz was just adding, just reading the comments here, missing data is caused by wrong interrupt priorities. This could happen to you. So going back to those, if you're using those async configurations, you want to make sure those priorities are in sync. But highest in terms of priority. Yeah, Saeed, I hope that helps. Hopefully you figure out the bugs. Hopefully you can use the async implementation. I think that would help you. But all right, I think that's it for questions. I'll give you guys like 2 more seconds. Otherwise, you can leave it in the comments below, and I'll get back to you. When I get those messages in my email box, I go, whoa, someone's got a question. So I head over there and I try to do the best I can. Or if you have suggestions, leave them in the box below. All right. Well, thanks for being here, and we'll see you on next week's rendition of Zephyr 101. All right. See ya.